All right, now we're on example 3, solving problems with systems of equations. Example 3, solving problems with systems of equations.
You know, it's not just looking at fun math puzzles that our math teachers give us or that you and I think about together. Actually, looking at equations where we have lots of unknowns and lots of equations, so systems of equations, they actually appear all over the place. And not just in math and science, sometimes even in the arts. Let's take a look at an example where we can see systems of equations coming into play while making a quilt. Let's check it out together. So a quilt designer is creating a new pattern on the computer and needs to know the coordinates of the point where the line connecting the point A to B will intersect the line connecting points C and D. So here's our challenge. What point do the two lines intersect? So where is that point of intersection? So check it out. Here is this great little part of a quilt, a little pattern that she's apparently going to sew into something much more elaborate. And what we have to do is we have to figure out, in fact, where is the point of intersection that connects the line A, B, those points. And in fact, I can actually show you that. Let me show that to you right now. Because I actually have it. That's how good I am. Look at that. So there is the line, oops, there is the line connecting the point A to B. That's good. And now I want to connect C and D with a line. I'm going to actually put a different color line just so we can see the difference. So here's the point C to D. Oh, that looks beautiful. I don't know. It's good. Okay, and now the challenge is to find out that point where those two lines intersect and find the coordinates of that point. So you can kind of eyeball it. You can kind of see roughly where it is, but I want to know the exact precise values. So how would we proceed? Well, the first thing we do is we notice that we can read off the coordinates of the points A and B and C and D. And then since we know that 2 points determine a straight line, we can actually find the equation for this line that connects A and B, and then find the equation for the line C and D. Then we'd have 2 equations and 2 unknowns. We'd have a system of equations that we could solve them. Okay, so lots of stuff to do here. Let's first of all just start by finding the equation of the line that passes through A and B. So what is A? Well, A, that's a point that has coordinates 4, 3. So that's 4, 3. And then B, let's see, B is way over here. So that has coordinates -4, -1. So we have -4, -1. So to find the equation of a line, we have to first figure out the slope. So what's the slope of this line? So the slope is equal to the change in y over the change in x. And so in this case, if we take the change in y, we're going to take, let's say, 3 minus -1 divided by, remember, since I took this y first and that y second, I'm going to divide it by this x first and this x second. So I'm going to have 4 minus -4. And so what does that equal? Well, 3 minus -1 is just the same thing as 3 plus 1, which is about 4. And then 4 minus -4 is 4 plus 4, which is, of course, 8. And so we see that this simplifies to just a half. Aha! So the slope is a half. Now, what's the formula for a line? There are lots of formulas for lines. Let's just pick one that I happen to like. Let's look at y equals mx plus b, slope-intercept form. So now I see that the slope is 1/2. Excellent. So I see that y equals 1/2 x plus b. So now we have to find b, which is the y-intercept, which is kind of where that blue line is crossing the y, and you can see kind of roughly where it is, but I need to know exactly where it is. So what do? I'll take one of the points that I know. Let's take 4, 3, and just plug it in for x, y, and see what we get. If we try that, we see for a y, I'm putting in 3, and for x, I put in the 4, and that has to yield an identity. And 4 divided by 2 is just 2, so this becomes this equation, and that's really easy to solve. You subtract 2 from both sides, and you see that b equals 1. So that's the y-intercept. So in fact, this picture is not exactly perfectly drawn, but that's okay. It's hard to draw a perfect picture, but we see that this makes sense. It looks like it could be right around 1, but we see it's exactly at 1. So the bottom line is we now have the equation for this line. The equation for that line is y equals 1/2 x plus 1. And now all this work, we can get rid of it. It's not important anymore.
Okay, now notice what he did here when he found the slope. Don't forget your equation. Slope is m, that slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Don't forget that. Okay, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. Now also, pay attention to your basic math. Alright, so here he's saying that this right here is his y sub 2. So that's the 3. Right? That means that the negative 1 is his y sub 1. Right there. Alright? Now, so x then has to be his, 4 has to be his x sub 2. And negative 4 is his x sub 1. Now don't forget, a negative times a negative is a positive, so 3 plus 1 will give you 4. I said that wrong. A negative times a negative is a positive. Right, no, I said it right. Negative times a negative is a positive, so 3 plus 1 will give you 4. Down here, negative times a negative will give you a positive, so 4 plus 4 will give you 8. Reduce that, and it's 1/2. So now you know your slope is 1/2. And don't forget the equation, y equals mx plus b. Y equals 1/2 x plus b. M, we found, was 1/2. So now we're going to find b. We're going to find the y-intercept. And to do that, we pick any one of these two values. Doesn't matter which one we pick. 4, 3, negative 4, or negative 1. 4 and 3 is easier to work with because both of the numbers are positive. So y is 3, and x is 4. So now we got 3 is equal to 1/2 times 4 plus b. All right. Now, what is 1/2 of 4? That's 2. So now we got 3 is equal to 2 plus b. We want to get b by itself. So that means we got to subtract that 2. Subtracting that 2 means we end up with a negative 2 here and a negative 2 there. That's going to cancel out. 2 minus 2 is 0. And then b is equal to 3 minus 2, which is 1. That's how they came out with that. 3 minus 2, which is 1.
It's done its job. Let me see if I can do this without now. This might not go well. Oh, no, it went very well. Look at that. Look how good I am. I'm so good. All right, so what we see now is that the equation for the blue line is exactly that. Now, we can do the exact same thing with the equation for the red line. And in fact, you could actually notice, and it turns out to be a reality, that the red line actually passes through the origin. And it turns out that's actually the accurate depiction of the line. So in fact, the y-intercept will be 0. And if you look at the slope, you see that I've gone from this point 2 down. So that's negative 2 and 1 over. So that's 1. So that's negative 2 over 1. So the slope is negative 2. And so in fact, very quickly, we see the equation for this line is, in fact, y equals negative 2x. Well, now we have our system of equations to solve. It is, in fact, and I'll write the fancy way that you know, sometimes we see, it's y equals 1/2 x plus 1 together with y equals negative 2x. And I put those nice little curly brackets right around it because it's the system of those things. And the pair xy that satisfy both this and this, in fact, will be the place where they meet. Okay, so now let's just solve. Well, we can now substitute because I see that y equals this, but y equals that, and so I can now just plug in and say, okay, in place of that y.
All right, now for those of you who may be confused as to how he came out with a negative 2, it's real simple. See, this is the line you're looking at right here. Right? And see how the line crosses at 0? That tells you that your y-intercept is 0. So in the equation, y equals mx plus b, in the equation y equals mx plus b, your b is 0, so there's nothing there. So far then you have y is equal to mx because that b was 0. Now to find the slope m, in this case you can count from one point to another. So notice how you went down 1, 2, that's your rise, that's a -2, and your run is a +1. So you end up with y equaling -2 over 1, that's your slope, times x. What's a -2 divided by 1? That's equal to a -2x. That's how they came out with y is equal to a -2x.
I'm going to insert this twin for the y right into there. And when I do that, what do I see? This top equation will become -2x, because that's what y equals 1/2 x plus 1. Great, and now I can solve for x. And so how do I solve for x? Well, let me take this 1/2 x and kind of get it to the other side. So how do I do that? Well, to undo the 1/2 x, I'll just add 1/2 x to both sides. And so let's see if that's exactly what I want. Why would I add when I really need to subtract? I did it in red. So now why did you tell me that I should be subtracting? I'm mad at you now. All right, but I'll forgive you very quickly. So what I'm going to do is I'm just going to actually get rid of all this stuff, and that should be subtracting. Right? Because to undo addition, you have to subtract. Don't be so silly. All right, I've forgiven you. We're all friends again. Okay, now on this side, what do we have? So here I see -2x, and then I'm subtracting another 2x. So that's -4/2 x minus 1/2 x is -5/2. So I see -5/2 x on the left, and on the right, these simplify to 0. I'm just left with a 1. And so how do I undo the multiplication by -5/2? I multiply both sides by -2/5. So if I do that, then on this side I see times -2/5. And on this side I see -2/5 times 1. That's going to be easy. This simplifies to just x, and this simplifies to -2/5. Great. So I see what x equals. X equals -2/5. So am I done? No. Because I still have to figure out what the y value is. That's just the 1/2 of defining the point, right? I need the y coordinate. But that's really easy to do because any one of these equations will work. I always use the easier equation for me, and so I'm going to use the second equation. So all I've got to do there is plug in the x value we now know is -2/5. If I plug that in for the y, I'm going to see what y equals. So y equals -2 times x, which is -2/5. And that just is easy to figure out. That's y equals, well, a negative times a negative is a positive, and 2 times 2 is 4, so this is 4/5. And so we see the final answer, after all that great work of ours, we have x first. Let's not write it in the wrong order. So -2/5, comma, and then the y value is 4/5. And that represents the answer. That means that when x equals -2/5 and y equals 4/5, both of these equations are satisfied simultaneously. So we found the solution to the system of equations, and that actually corresponds to the point of intersection. And now let's check it out and see how close our picture is.
All right, now for those of us who may be confused right here, how you went from a -2x minus a 1/2 x, and it came out with a -5/2. A -2 and a -1/2, when you add them together, that comes out to be a -2 1/2. All right, now convert that to a improper fraction. You're going to say 2 times 2 is 4 plus 1 is 5. So 5/2, and don't forget your negative sign. So that's how they came out with the -5/2 right there.
2/5. So that's kind of around -1/2. That's kind of between 0 and -1. So that's kind of where this is. And how high is it? Well, it's 4/5, which is a little bit less than 1. And you can see it's a little bit less than 1. So this picture is actually pretty close to being accurate. But we see the exact accuracy the moment we actually start to write down equations and start to solve. In this case, systems of equations. So, whether it's quilt or whether it's